Haptics. By now you know, the rumble in your game controller or the vibration in your phone. The interaction we feel through touch is what we call haptics. But there's more to it, right? Developed by Nokia Research and the Helsinki Institute of Information Technology, the Force Phone took pressure feedback from a caller who would give it a good squeeze, and then the receiver would get differing strengths of vibration based on the strength of the squeeze. With a stronger squeeze, you would get a stronger vibration. They called these vibrations presages, like messages. As part of the project, the short study was conducted between couples and long-distance relationships, and it was found that in general, the use of presages allowed for easier and better communication by aiding in expression. I know, it might seem silly, but it's a way to communicate touch. Hey, who knows? Maybe you'll see it in your next phone. But moving on, you've heard about smartwatches, right? Maybe you have one. We can take a quick look at the article, A Smartwatch with Embedded Sensors to Recognize Objects, Grasps, and Forearm Gestures. It was investigated how the use of pressure as an input on a wristband could effectively be used to detect whether a user was holding an object or not. Okay, so when you hold an object, your tendons in your wrist are pulled, creating a pressure that could be detected by an array of sensors around the wrist. The experiment itself had users place their hands in different configurations in order to see if there was any useful data to be gathered in regards to recognizing different hand gestures. It was found that depending on your wrist shapes and muscles, there was a significant variation between person to person. We are unique. There's no one-size-fits-all solution. But despite that, the researchers had found that the individual data was consistent to the point that it could recognize finger gestures, hand gestures, and grasps. Could this be used in a personal device such as a smartwatch? I mean, a user could calibrate or train the device to learn his or her own unique gestures. We already know that accelerometers and gyroscopes are a bit useful in recognizing hand gestures, so combining that sensor data with this new data could be used to enhance augmented reality or help with realistic interaction in virtual environments. Let's jump into the devices that are already out on the market. We can look at the Samsung Galaxy Gear. The article, The Office Smartwatch, Development and Design of a Smartwatch App to Digitally Augment Interactions in an Office Environment. Here, a group of researchers experimented with the Samsung Galaxy Gear. The Galaxy Gear is a multimodal device that allows visual, audio, and vibration feedback. It has a microphone, a touchscreen, and a camera that can all be used as inputs. These researchers found that it was possible to track simple gestures such as knocking and twisting. But how the heck do users know if they've completed some odd gesture? Well, it was found that it was pretty important to present audio feedback, so that you know that you're doing things right. Something as simple as a knock, accompanied by a knock gesture. So yeah, smartwatches, they're kind of interesting. Who knows, maybe a little bit gimmicky. Yet they aim to deliver wearable computers to far more users. How neat would it be if your watch could tighten up as a reminder or warm up when you get a phone call? Right now, we're in the early days of wearables, just waiting to see what practical and innovative uses we will find for them. Now look, as we try to create more immersive technologies and look into a developing realistic virtual world, haptics are the key to all of this. An interesting method of displaying haptic objects was developed by the researchers at the University of Bristol using ultrasound technology. These researchers, they found a way to create 3D shapes in midair. They found that using ultrasonic force, you could create a tactile sensation. Using 3D objects as a reference in midair, it was possible to create an experience where a user could just walk up to a display and feel an object with their bare hands. The general principle was to use an array of ultrasonic transducers that generate a force when somebody puts their hand over a 3D virtual object. Using the Leap Motion, a device that's used to detect the positions of your fingers, a 3D model of a hand could be created in a system in order to detect polygon collision between the 3D objects, kinda like in any game. This would trigger the ultrasonic transducer array to send appropriate feedback, and what you end up is with a user that could feel a virtual object in real space. Pretty neat. Who knows? Maybe soon enough we'll see this in a local kiosk. But hey, check this out. The Kinetic Device, an experimental, flexible mobile phone developed and researched by the Nokia Research Center. The Kinetic Device itself is a mobile phone made of flexible materials that allow you to bend and twist the entire phone so that you can perform different actions such as zooming or scrolling. Both actions that come very naturally, very intuitive, and require very little learning. Those are kind of neat devices, neat what-ifs that show what could be done, what has been done, and what might be done. Obviously, what can be done and what will be done are different stories. But we know that before we see any of this, whether it be flexible phones, pressure communication, or 3D touchable displays, it has to be demonstrated first, and that it has. With time, you might see some of this technology that pushes the boundaries of interaction. Hey, I hope you enjoyed that video. If you did like it, do hit that like button, do share, and as always, no matter where you are in this world, have a good night, a good morning, a good day. Bye-bye.